Hello everybody, welcome to this lesson on DHCP snooping. I'm glad that you've joined me in this lesson. So what we're going to be learning in this lesson. Firstly, let's just see where DHCP snooping is actually mentioned in the CCNA topic. So in section 5.7, we see that we configure and verify layer 2 security features, DHCP snooping, dynamic ARP inspection, and port security. So we asked here to know how to configure and verify DHCP snooping, which is very high level of understanding. When we're asked to know how to configure something, that is a very deep level understanding we need to have in DHCP. So it's not just describe DHCP snooping. So we're not just asked just to describe DHCP snooping or define DHCP snooping. We're asked to know how to configure and verify DHCP snooping. So it's a quite deep level understanding we need to have here. So what we're going to be covering in this lesson, well, firstly, we're going to be looking at DORA, and I've made a slight extension to this acronym by adding Doctor to it. So Doctor DORA. What is Doctor DORA? I'll explain. Then we'll be looking at actually what DHCP snooping is. Then the DHCP snooping logic. Following on, we'll be looking at some of the attacks, DHCP attacks, and how DHCP snooping can come to the rescue and prevent these situations. And then finally, we'll be looking at key commands and a short quiz at the end. So quite a lot to cover, so let's get straight into it. So firstly, meet Dr. Dora. Who's Dr. Dora? Well, you might be familiar with the acronym DORA. So this is the DHCP flow: discover, offer, request, and acknowledge. It's the normal DHCP flow, okay? But there are additional DHCP messages which might not be actually directly related to the standard flow, but they are important. So decline and release, and these might get overlooked. So this is why I've added them onto the DORA acronym. So to make Dr. DORA, but remember, the DORA is the standard flow. This is the standard flow for a DHCP request. But decline and release messages are two messages that can that also can come into play and are also important. So firstly, let's look at clients and servers. What do the clients send? What do the servers send? So the clients send discover and request messages. So this client, if I'm PCA and I want to communicate on a LAN and I need an IP address, well, I will send a discover message to the DHCP server. The server will receive it and offer me an IP address. Now and then that offer gets back to me in a request. The server will offer an IP address, then the offer gets back to me, and then a request from the client is sent back to the server, say, yes, I want the IP address, please lease it to me. And then the server actually sends the IP address in an acknowledge message. Thus a 4-message flow there. Now, there might be cases where IP addresses need to be turned down or relinquished. So decline is to turn down an IP address during the normal flow. So if the client doesn't want it, it doesn't have to accept that. So in a request. So instead of a request, you could have discover, offer, decline. So a decline, okay? And then we've got release. And a release is when a client already has an IP address, but it no longer wants it. Apologies. So what it does is it can send a release message when that IP address is no longer needed. So that's Dr. Dora there. Now, what is DHCP snooping all about? Well, DHCP snooping is a security feature that's there to protect us from DHCP-related attacks. So defined here is DHCP snooping is filtering DHCP traffic in order to prevent malicious traffic from rogue DHCP hosts and rogue DHCP servers. You see, the actual protocol, dynamic host configuration protocol, is something which can be exploited, and the attacks that can be just like how I just spoke about release messages, okay, which is to relinquish an IP address. Well, the release message can be exploited, and I'll show you later on in this lesson, but a release message can be exploited. And so there are DHCP protocol related attacks. Now DHCP snooping, we need to remember this is not an attack. DHCP snooping is a prevention against attacks. So it's a security feature, okay, and that's filtering DHCP traffic to prevent these kind of attacks from rogue hosts and rogue DHCP servers. So let's look at some key facts about DHCP snooping. Well, firstly, DHCP snooping only filters DHCP traffic. It's very important to remember. It does not filter non-DHCP traffic. So if you're in an exam and you get asked this, remember it only filters DHCP traffic. The non-DHCP traffic is not affected. It won't do anything to it. Now, then we need to look at DHCP snooping. It works on a per VLAN basis. So this is very important. When it comes to configuring DHCP snooping, you will see that you can only you have to first globally enable DHCP snooping, and then you have to enable it per VLAN. So this is something very important. And then finally, VLAN ports. When we're looking at DHCP snooping, our VLAN ports can be defined as either trusted or untrusted. So trusted are normally those networking devices like DHCP relay agents, switches that act as DHCP relay agents, and default gateways, routers, our legitimate DHCP servers. These are normally connected to trusted VLAN ports. Normally they connect to trusted VLAN ports. The untrusted ports are normally connected to end-user devices, because those are the ones that normally can cause normally the issues are related to end-user devices, rogue end-user devices that are trying to initiate attacks. So trusted or untrusted ports. That's very important to remember. Now, DHCP snooping, remember this, provides a layer 3 service, but it's commonly enabled for layer 2 switches and enabled on layer 2 ports. It provides a layer 3 service, but it's commonly enabled for layer 2 switches and enabled on layer 2 ports. Service is layer 3, but we enable it on our layer 2 switches and enable it on our layer 2 ports. Now let's actually look at the logic. How does the DHCP snooping make its decisions? Well, firstly, DHCP snooping examines all the incoming DHCP messages, and then it has to make some key decisions now. So the client untrusted ports. Now, the client untrusted ports. If we've got incoming DHCP messages that are from those untrusted ports, there needs to be a further investigation done, because they're untrusted ports. So here we've got our own separate we've got a separate, this now decision making branches out. So we've gone from examining all the incoming messages. We're now specifically filtering these messages. Okay, so you have that initial examination, seeing are they from client untrusted ports, or are they from DHCP trusted, or the DHCP messages from trusted ports, or are they from, or they DHCP service messages from untrusted ports. So you see this. So you can have client untrusted ports. You can have you can have TCP server messages from trusted ports. So okay, from trusted ports, or DHCP server messages from untrusted ports. Client untrusted ports. These are the checks that's done. So firstly, need to check the MAC address consistency between the Ethernet header and the client hardware address. So in our Ethernet frame, we'll have a header, and there you'll be able to see the source MAC address. The source MAC address. If I take you guys here, you might recognize this whiteboard from a previous video, but this is what is happening here. So our discover messages sent by the client are examined. So Ethernet header and the CHADDR client hardware address value, which also contains MAC address. These are checked. If there's consistency, if they're the same, then we accept those messages. If there's a discrepancy, if they're not the same, then those are discarded, because we know those are being. That's because when there's a discrepancy, that's proof that they are not legitimate, because they have to match. They must match. So that is what happens. We check the Ethernet header, which contains source MAC address, against the client hardware address value. And if we go back to our slide, on our logic, we can see here, look, first we're checking the MAC address consistency. Now, if the MAC addresses are consistent, this message is accepted, and an acknowledged message from our server with the the acknowledged message which contains the IP address is we go through the normal DORA flow. The acknowledged message from the service sent to the client. The client has now received an IP address, and that results in the binding table updating, which is reflecting that DHCP release. The binding table shows us the IP addresses and the IP address and against the MAC address of the device. So the least IP address against the MAC address of the client. Now that's what happens on the DHCP on the DHCP snooping enabled switch. This is what's happening. The binding table, just the database that's containing the IP address and the MAC address of the clients to be able to do checking. So now if we move on to release and decline messages, specifically the incoming interface and the IP address are checked against the DHCP snooping binding table. Remember, release and decline, those are two special types of messages which can be sent from the client to have its IP address relinquished, taken off it, or to reject an IP address that's been offered to it. So the binding table entry gets removed when the IP lease expires or the server receives a DHCP release message from the host. So as long as we can see that the interface matches the binding table, I'll show you guys what I mean, but as long as the interface matches what's in the binding table, that's accepted. But there has to be that check done against the binding table. Now, moving on, DHCP server messages from trusted ports, those are all accepted. All accepted because those are device connected to trusted ports. We know that this is the legitimate DHCP service connected to a trusted port. Therefore, they're always accepted. There's no filtering done there. The messages are from untrusted ports. If there's a DHCP server message coming from an untrusted port, we know 100% that is dodgy, that is not legitimate. Those are all rejected because we can't have DHCP messages, DHCP servers connected on untrusted ports. That cannot happen. Whenever we see something like this, that's automatically a red flag, and those messages must be rejected. So we've kind of touched on it, but we're going to go into this deeper now. Dangers of living without DHCP snooping. What are the dangers associated? Well, we've just spoken about trusted and untrusted ports. So remember, DHCP traffic for trusted ports are forwarded. DHCP traffic on untrusted ports normally sent by a client may be filtered, and DHCP traffic on untrusted ports normally sent by a server are discarded, because that's a red flag. This specifically referring to offline acknowledged messages, because those are sent by servers, whereas the discover and request are sent by the clients. Now, just a summary: clients send discover and request messages. Server sent offer and acknowledge (ACK) messages. Now, the first attack is a starvation attack, DHCP starvation. What does that mean? Because obviously starvation, normally, when you think starvation, we think of a person deprived of food. What's DHCP starvation? Well, we saw here that discover messages can be filtered, and this filtering is by doing an examination of the Ethernet header, MAC address value, and the client hardware address, MAC address value. Now that is done, and those filter out the legitimate requests against the non-legitimate requests. However, what this is actually preventing, this feature is preventing, if we didn't have this, what would happen is this client here, this rogue client, we'll call this PCX, could request as much IP addresses as it wanted to until the DHCP pool of IP addresses is completely exhausted, is completely finished. So that is the danger, that is a starvation attack. So this, the DHCP snooping prevents this from happening. It prevents starvation attacks. And then we look at the second type of attack, DHCP poisoning, also known as a man-in-the-middle attack. What is this? Well, here we've got PCX, and this is a rogue host. And what it does is, it deceives the PC1, which is here, to believe that the PCX has the IP address of the default gateway, router 2. And this results in PC1 thinking that the route passes to that PCX is the default gateway, so it sends everything to the default gateway, so to PCX, which in turn will receive everything and then send it to the legitimate default gateway. So whilst everything does go to the default gateway, it's going through PCX, which is a major problem. You can think about this from an enterprise point of view. For example, you had HR. So you had a disgruntled employee who's PCX, who deceives the HR, the HR administrator into believing that PCX is the default gateway. So if HR needs to send an email out to the internet, it's going to go through PCX. And from a security point of view, that could result in so much confidential data being exposed to an unauthorized threat actor. So that is there's extreme consequences. It's the same thing with with other types of business business professionals, such as finance people. If you have a finance administrator sending confidential information through the wrong through a rogue device, that can result in credit card information and bank account details and so many other financial information being exposed. So it's a major issue if this happens, and and these things can happen. So this is why we have DHCP snooping. Now, one of the reasons why we have DHCP snooping is to prevent these kind of attacks, because this would not have happened with DHCP snooping. So the question is, could DHCP snooping prevent the DHCP snooping poisoning attack? And as I've just confirmed, yes, it was preventable. How though? Can anyone think how DHCP snooping would have prevented this? Well, let's look at the answer. So the attack could have been prevented by making the port connected to the port that PCX had, which was connected to the switch, untrusted. Had that port here on switch 1 that's connected to PCX been an untrusted port, this could have been totally prevented. Unfortunately, that wasn't the case. So PCX exploited this vulnerability in the LAN and made this PC, which you can't see now, but they made that PC1, believe that PCX was the default gateway. Had switch 1, we had enabled DHCP snooping, and we had this port here as an untrusted port, as it should have been, because this is a client, regardless of being rogue or not rogue. It was a client. And we should not be all client ports should be, these should be, our client ports should be untrusted. Because we didn't do that, this led to this attack happening. So it could have been prevented. Now, the last type of attack is a malicious DHCP release message. So, as you remember, I spoke about DHCP release messages. Now, this is something that can also be exploited. How? Well, if you look here, we've got an attacker. Now, again, we're going to call this PCX. Now, this sees that this attacker knows that PC1 has this IP address, 172.16.2.105. That's the IP address PC1. This attacker wants that IP address. So what it does is it attempts to send a release message saying, please release 172.16.2.105 to the DHCP enabled switch. The switch, however, because DHCP snooping is enabled, it carries out an examination, doesn't just straight away follow blindly any requests from untrusted ports. So what happens is it checks the actual interface that this release address message claims to be from. And what it finds is, when it checks the binding table, is that interface does not match what's in the binding table. That's G106 in the release address message. However, the binding table says G105 is the interface that connects to PC1. So what happens is this message is rejected. That is rejected. It's not listened to. So we reject this release address message. That is rejected because the binding table has confirmed to us that this was not a legitimate request. So that's the third type of attack that can be prevented. Now, there's a short video on YouTube as well about this, for you guys to review as well, which is specifically just because it talks about this attack. Now, moving on. So DHCP snooping has come to the rescue in these previous attack situations where we could have had here, what could have happened? Well, this IP address could have been taken away from PC1 and given to the attacker, and the attacker could have caused major issues in the network. This attack here could have caused major data breaches, major security violations had this PCX been able to to be able to see everything that PC1 is sending. And that PC1 could be a finance person, an HR person who's trying to communicate with people of the internet and sending bank account information and credit card details and so many other types of confidential information. It could be healthcare records, who knows. And so this kind of information would have been a leak to an attacker. And finally, here we got this DHCP snooping in this situation has prevented all of our IP addresses from being leased to a rogue client. So DHCP snooping has saved us in these three situations. It could have saved us in these three situations, as we saw in this one. This attack was not prevented. This was allowed to happen here. But as we saw, this could have been prevented had this port been untrusted. Now, let's look at some commands for DHCP snooping. Well, firstly, IP DHCP snooping. So, if you remember, I said earlier that there's two commands. We need to enable DHCP snooping globally and then enable it per VLAN because it works on a per VLAN basis. So, firstly, we have to enable it globally. So we do IP DHCP snooping. We configure that on our switch, and then we do IP DHCP snooping VLAN followed by the VLAN number to enable DHCP snooping on that VLAN. So these two commands work hand in hand. And then, if we want to configure an interface as trusted, we can use this command, IP DHCP snooping trust. And if we just want to verify the DHCP snooping configuration, we can use show IP DHCP snooping. Now, if we want to check source MAC address against the CH80DR value, we can configure our switch to do this using the command IP DHCP snooping verify MAC dash address. Okay, moving on, more key commands. If we want to enable option 82, IP DHCP snooping information option. Well, what is option 82? Option 82 is something we can configure on a switch, specifically on relay agents, DHCP relay agents, which are forwarding on DHCP messages from client to the DHCP snooping from our client to our DHCP snooping enabled switch. So this is something that is used to forward those messages on, because what happens is option 82, what it does is it holds additional information from the clients about them that we can use, that the DHCP snooping enabled switch can use to help it in its decision making, to determine whether those messages should be allowed or dropped. So it's something that we don't actually, it's something that we configure on the switches between the path from our client to our DHCP snooping enabled switch, because you might have 2 or 3 switches between or more, but the thing is option 82 needs to be enabled. So it's an additional feature that we can use, but we should only be using on our relay agents, not our end user devices. So that is to enable this IP DHCP snooping information option. And if you want to disable, then it's just repeating the same command, but we put no at the start. And then finally, clear IP DHCP snooping binding. This removes entries from the DHCP snooping binding table. So those are some key commands about DHCP snooping. Now, let's get to the quiz now. So this is the first question in this quiz. It's a 4-question quiz. True or false? Untrusted interfaces should not be connected to default gateways. Is that true or false? Untrusted interfaces should not be connected to default gateways. I'll give you an opportunity to pause the video and then please play when you're ready. So please pause the video now. Okay, so let's have a look at the answer. Untrusted interfaces should not be connected to default gateways. True or false? And the answer is true. Untrusted interfaces should not be connected to default gateways. Second question. True or false? Although DHCP snooping provides a layer 3 service, it works on layer 2 switches and enabled on layer 2 ports. True or false? Although DHCP snooping provides a layer 3 service, it works on layer 2 switches and enabled on layer 2 ports. True or false? I'll give you the opportunity to pause the video. Please play when you are ready. Okay, so let's have a look at the answer. The answer is true. So although DHCP snooping provides a layer 3 service, it works on layer 2 switches and enabled on layer 2 ports. Question number 3. Which command do we use to disable option 82? Which command do we use to disable option 82? So again, please pause the video and play when you are ready. Okay, so the answer is no IP DHCP snooping information option. That's what we use to disable option 82. And finally, question number 4. True or false? DHCP snooping is enabled on a per VLAN basis. DHCP snooping is enabled on a per VLAN basis. Again, please pause the video and play when you're ready. Okay, so let's have a look at the answer. And the answer is true. So DHCP snooping is indeed enabled on a per VLAN basis. So that brings us to the end of this video. Thank you so much for watching. If you've enjoyed this video, if you learned from it, please like, share and subscribe. I really appreciate it. Thank you so much, everyone.